Now we see next topic, distance of a point from a line. Suppose given point is P and given line is AX plus BY plus C equals to 0. So if the coordinate of this point P is x1, y1, this concept we discussed in class 11 for two-dimension system. So we write distance of a point from a line, that is perpendicular distance. If that distance is d, we write the formula d equals to, in root, we write the equation of line ax plus by plus c and replace the value of xy by the coordinate of point from which we required a perpendicular distance of that line. So we replace this x1 y1, x and y by x1 y1 upon under root a square plus b square. Now this is concept for two-dimension system. In this chapter we have to consider three-dimension system and equation of line in vector form and position of point with respect to some fixed point, or we can say only this point P with position vector. So if this line is r bar is equal to a bar plus lambda into b bar, that means this line pass to the point with position vector a bar and parallel to the vector b bar, and position vector of this point P is P of alpha bar. Then we have to find distance of point P from this line in terms of vector. So theorem is, so the topic is distance of a point from a line, and theorem statement of this theorem is the length of perpendicular of the point P of alpha bar from the line r bar equals to a bar plus lambda into b bar is given by in root magnitude of alpha bar minus a bar its square minus alpha bar minus a bar dot b bar upon magnitude of b its bracket square. So here point P with position vector alpha bar is given. The distance from the line r bar equals to a bar plus lambda bar into b bar we have to find, and that we find by using this formula. Now if instead of position vector of point P, its coordinate is given as P of ABC and equation of line in terms of Cartesian form x minus x1 upon L is equal to y minus y1 upon L is equal to z minus z1 upon L. Then the distance of this point P from this line is given by, we write here alpha bar minus a bar. So instead of alpha we have the value ABC, so we write here a minus x1 its bracket square plus b minus y1 its bracket square plus c minus z1 its bracket square minus, then here alpha bar minus a bar dot b bar upon magnitude of b bar. So instead of this we write here LMM, so we write here a minus x1 into L plus b minus y1 into M plus c minus z1 into N its bracket square. So by using this formula we can find distance of a point P of ABC to the line x minus x1 upon N is equal to y minus y1 upon M is equal to z minus z1 upon N. Now next topic is skew lines, that is non-coplanar lines. We know that when we say given vectors are coplanar, we know that when vectors lie in the same plane or in a parallel plane are coplanar vectors. Suppose a bar, b bar and this vector c bar. Now these three vectors are coplanar when these three vectors lie in a same plane or in a parallel plane. Now if these two vectors vector A bar and B bar are intersecting, then their distance between these two vectors, or in place of vector we consider two lines. That means when distance between two lines is 0, that means that two lines intersect. But when these two lines are parallel, that means that line do not intersect. And when line is neither parallel nor intersecting, then that type of line is called skew lines, or we call non-coplanar lines. And the distance between these two lines, suppose this line is L1, this line is L2, then the perpendicular distance, suppose segment AB is perpendicular to both line L1 and L2, then the length of this AB is the distance between these two skew lines. You have to just remember, when these two lines are neither parallel nor intersecting, then these lines L1 and L2 are called non-coplanar line or skew lines. Now next topic is distance between two skew lines. So theorem of this statement: if R bar is equal to A1 plus lambda into B1 bar and R bar is equal to A2 bar plus lambda into B2 bar, so in place of lambda we take mu, are two skew lines, then distance between them is given by D equals to, so we take here A2 minus A1, A2 minus A1, vector A2 minus vector A1 dot B1 bar cross B2 bar upon magnitude of B1 bar cross B2 bar. So using this formula we can find the distance between two skew lines. If given lines are R bar equals to A1 vector A1 plus lambda into vector B1 and R bar equals to vector A2 plus mu into vector B2.